here that states of data, that the data that you have has also certain states. So there are three states to your data: the data in transit, data in data at rest, and data in use. Let's talk each one of the states of data that also comes in IPsec. Now let's talk about data in transit. So transit means that while you're communicating, if this user communicates with this user over insecure networks, okay, so the data is sent over to the different networks, and if the data is transported between different locations, correct, or you can say nowadays there are cloud systems or cloud services that comes in picture. So there are trusted and untrusted networks. So we should we should make a proper medium of communication where if the data is transferred between the location, so we need is secure communication, correct. Now, how secure communication is achieved? By performing all the CIA traits, or a communication medium where you propose encryption, authentication, hashing. With the help of that, this is achieved, right? Now, what are the threats to data in transit mode, right? So the threats are: first is man in the middle attack, right? What is man in the middle attack works is that any unauthorized user or attackers try to access in the middle and eavesdrop your conversation, and whatever he got the information from your communication, he can takes action. For example, if you perform a online payment of your e-commerce to your e-commerce website, and somebody in man in the middle attack tries to eavesdrop your credentials, that's where this is threat to data in transmit. This is just the example. It also be achieved using packet sniffing. So I think you have tried out Wireshark, where you just sniff to your Wi-Fi network, that all the devices that are connected, and you got to know each packets and the detailed packet information also. If your traffic is HTTP, then everything is just visible over there. If you want, just perform a basic visit to the HTTP website where they ask for username and password, and under sniffing you get the username and the password details also. So this all comes as threat. Also, I want to add one another threat as DNS spoofing, that the attacker tries to give the attacker's DNS server. So whatever queries sent by the client to the server will first go to the attacker DNS server, and it send us to that particular malicious websites where he can track that particular user and takes his access. Okay, so this is how data at transit works. Now, data at rest. Data at rest means that the data that is stored on the device or the medium. So let's talk about data at rest, right? So if the data at rest, so what we look under that is that the stored data, right, or the medium on which it is stored, such as hard drive, cloud storage, or the database, right? How we can keep the data safe, right? This is our concern, right? So what we do is that we perform encryption on that data, that even if the unauthorized user gets the access to the files or the data, cannot be accessible to that because it's encrypted, right? So this is all about rest. And what are the threats that to data at rest, right? So the threats here are physical theft. Okay, physical theft means that somebody physically got the duplicate key to your office, enter to your office, and takes all your data. Or you can also, it can also be achieved using unauthorized access, right? So under unauthorized access, exploiting permissions and privileges, right? And takes the access of that particular data. You can also add here as data leakage, means the data is leakage, means if your credentials are visible to outside world, or not outside world, even inside your organization, somebody just mislead your data and or you can also say accidental exposure, right? Also, there's one thing as insider threat. So insider threats are basically your inside organization. There is somebody who just tries to access the stored data, your malicious employee. Okay, then also we add here as ransomware attack. So ransomware is something where somebody um, just encrypt your stored data and demanding for the payment for the decryption, right? So you have to pay in ransom to get your data back. So this is all are the threats uh, that comes with data at rest, right? Okay, so data in use is basically the data on which you are working. So it should also be encrypted as if somebody, as in somebody sniffed the data, means that somebody is sniffing your data. So the data in use should also be taken care. Okay, so it actually means that this is the state where it is being read, modified and manipulated, but not stored permanently on the device because the data is in use, right? So it's not stored permanently. This is something on which you are working on, right? But you haven't saved that data, you haven't stored that data. So the data is actually under processing, all right, because somebody is using that data. Now, what are the threats to the data in use? So the threats are basically that the attacker can exploit the vulnerabilities in the system to scrap the content of RAM, okay, or else sometimes there is a backdoor access also, backdoor access to your system, or can exploit the vulnerabilities. Means that first it check for the vulnerabilities in your system and then they exploit the vulnerability, okay. Or many software applications that processes sensitive data may have bugs and unpatched vulnerabilities that allow attacker to access the data in use, okay. So it means that the data or the application that you are using has certain bugs. So this all are the three states of data that also we covered now. Now there are few more definitions that I want to cover. So the first most important thing is data repudiation. Now data repudiation means that this is the assurance that somebody cannot deny the validity of their signature messages. For example, if a sender sent you the data, okay, to the receiver, and the recipient cannot deny that. So the receiver cannot deny that the data has not been sent. So somebody that cannot deny the validity. So it is basically the assurance, the assurance that that non-repudiation comes with. So it can, the non-repudiation can be achieved only using digital signature or public key exchange. So the example here is online transaction. So a user authorizes a transaction with a unique token or the biometric authentication ensured that they cannot deny performing it later. So for example, if you enter your biometric or your fingerprint, you cannot deny that you are not that person, right? Because you have authenticated you have authenticated yourself via that unique token or the biometric. Here under website also we perform digital signatures that assures that that particular information is correct, okay, and you cannot say later on that you cannot deny the validity, correct. So that this is how known repudiation works. Now gap analysis is basically, gap analysis is basically what we are doing and what we should do. So you should obviously look for security postures that in your organization, what are the loopholes. So by looking at your security posture means that you are looking at your firewall, your antivirus, your website firewall security. So this is all about gap analysis. So how gap analysis is identified? So it is identified by gaps are identified by missing security awareness training. So you should also provide training to your organization employee where that if any malicious user asks for the information or phishing should be performed, then how they are trained in particular situation. you can also look for the unpatched software. So if the software has no product key or it's not been activated, means the legitimate software is not activated in your organization, could also be the gap. That this is what are these are the ways from which the attacker look at the vulnerability and exploit your organization, right? Then also lack of incident response plan, means that if particular incident occur, what are your plans? So you should also look for that particular plans also, right? Then also, as I discussed, that also we want to cover up here that the phishing attacks to your employee, how your employees will um, going to save your organization by not providing any details uh, to the attacker, right? Now vulnerabilities. Okay, vulnerabilities means that particular it is a weakness, right? A weakness, you can say, of the organization or that particular system on which the attacker is trying to get the access, right? So there are certain types of vulnerabilities. So let's discuss that, as there are software vulnerabilities, there are hardware vulnerabilities, and there are configuration vulnerabilities. Now let's discuss each. That software vulnerabilities means that the weakness or the vulnerabilities in the software code. Yeah, so your code of data has any vulnerabilities, means that the examples are buffer overflow, right, or SQL injection. These are the example of software vulnerabilities where the user is entering the data more than the buffer value. So that's where the issue occurs with software vulnerabilities. The hardware vulnerabilities means that your hardware device. So the design, the flaws in your hardware design that can be exploited is called hardware vulnerabilities, right? Means that there are certain ports that are open in your firewall that could also be exploited by any of the attacker to get the access to your organization. Okay, configuration vulnerabilities, that could be the configuration of firewall, okay, or misconfiguration of the these are the types of vulnerabilities. Now stages of vulnerability cycle, let's discuss that as well, that what are the stages. So the first stage is discovery. Now the discovery is something that where the vulnerability is discovered. That if for example if you performed VAPT in your organization, so it could basically performed by security researchers, or you can say ethical hacker or penetration tester, right? These performs the discovery where they'll look for vulnerabilities in your organization. Okay, so these are the discovery, this called the discovery. Okay, so stages, you can also say it as life cycle. The second thing is disclosure. Disclosure is basically that the vulnerability is shared to the relevant team. For example, you look forward to how you can look forward to stop, or for example let's say a particular port that is enabled and you want to disable it because it's not in use, and that could be high chances that attacker should take any backdoor access using that particular port. Okay, so this is how disclosure comes. Now disclosure also have the multiple types. So the types of disclosure, the first is responsible disclosure. Responsible disclosure means that the discoverer, means whoever discovers, they're going to do the patching on that particular issue or that particular port. That could be before informing to the public, means that they'll just try to resolve the problem. Okay, this called responsible disclosure. Full disclosure. Full disclosure means that the vulnerability is made available to public immediately. Means that, for example, few years back you got to know that on iPhone there are certain settings that are by default enabled, and they should have to make it to the public before the attacker tries to exploit any of the phone, correct? So this called full disclosure. So just for the safety of the device before the attacker exploit the system, right? So when fix is available, this is called full disclosure. Then also there are 0-day disclosure. 0-day disclosure means that the vulnerability is disclosed and exploited by the attacker before the vendor even aware of it. So the example here are, you also aware about solar wind. So the solar winds is the type of attack where the attacker take the 20,000 plus organization details and their configuration files. This is called 0-day because the vulnerability is disclosed and exploited, and then after it came to know that this has been attacked or the vulnerability is found. Okay, so this is the second step. The third step is analysis. Analysis is something where the team investigates the vulnerability and find out its root cause or its impact and severity. So root cause is what are the root cause of that particular, then what are the impact, what are the positive or negative impact through that attack, and severity means that criticality. Okay, means it's like major, it's like critical, warning, critical, warning, and safe. So based on that the severity is given and the analysis is performed. Based on that they performed the patch development. Is, for example, if there's any loophole, they create the patch and they're just going to fix the vulnerability using that particular patch. Then also the manual patches are also available from the vendor website, and also there are configuration changes that could be made. It's all about vulnerability